All right, guys, this is going to be day 3 and 4 for our SOL review. This assignment that I'm going over now is going to be due Tuesday, the 27th, I think is the date. All right, so we're not having class Tuesday. Thursday of it's going to be the couldn't even tell you. Let me find the date real quick. But this you should be watching this on Tuesday, the 20th or the 21st. On the 22nd, we're going to be taking a quiz on the first 2 days, day 1 and day 2. All right, so this assignment is going to be due on the 27th. So make sure we get it done. It's 22 problems, 2 days worth of work. We'll come in on Thursday. We will do our quiz on section or day 1 and day 2 review. And then I'll talk about any of these problems that you did not understand, and then you're going to have time to finish it up. All right, so here's the answers for day 2. Pause it on here so you can check them. I'm just going to move on to the next part and into the lesson. All right, we're going to be solving equations today, all different types of equations. All right, first one, x squared plus 4x minus 5. As we do this, I'm going to do the problem by hand, and then we're going to come back and do it on Desmos to show us how we're going to check our work. All right, at any point I'm going too fast, pause it, and then catch up. All right, for number 1, we have 1, 2, and 3, 3 different quadratic equations that we're going to have to solve. Our thought, because it's an x squared, we're trying to find 2 answers. We're not always going to get 2, but we're going to look for 2. All right, the first way we're going to solve is factoring. So I'm going to factor this, and this is a straightforward factoring problem, and set it equal to 0. All right, because I have an x squared in the front, I put x and x. My last term is negative. When your last term is negative, it's always a plus minus. When your last term is positive, you use the sign in the middle. Now, I need 2 numbers that multiply to give me 5. And not add, I'm sorry. Subtract, since your signs are different, to get 4. I have 1 and 5. It's the only factors of 5. So I want to write, since my signs are different, do I want 1 minus 5 or 5 minus 1 to get my positive 4? And I'm going to choose positive 5 and a negative 1. Next, set them equal to 0. I get x equal negative 5. And x equals a positive 1. Those are my 2 answers. Now to check this on Desmos, I graph it just the way it is. One solution's at negative 5, 0, because I want to know where it crosses the x-axis. And the other solution's at positive 1, like we said. All right, this has 2 real solutions because it crosses the x-axis at 2 places. 2 real solutions, and they're rational because they're good-looking answers. If this was a crazy decimal, and let's pretend it was like this decimal, 1.11, or if it was something that's not a good number, we're going to say that's an irrational solution, a real irrational solution, because it's not a pretty answer. Rational answers are pretty, 1.5, negative 3.25. Those are rational. Irrationals are crazy decimals. All right, number 2, we're going to complete the square. My favorite way. We're going to complete the square and see what happens. All right, so if you don't remember, to complete the square, we're going to move the 10 to the other side. Underneath it, we're going to put a parenthesis squared. So I move the number to the other side and put a parenthesis squared. Hopefully as we do this, it makes sense. So I'm going to take this negative 6, and I'm going to take half of it and write x minus 3. We take half of the middle and get negative 3, and then I'm going to square this number. Negative 3 squared is 9. I'm going to put it in that space and onto the other side, giving me a negative 1. Next, to solve for x, I'm going to square root, but we have to remember, when you cancel a square, we do a plus or minus square root. So I'm going to say that x minus 3, because those cancel, equals a plus or minus. We talked about this last class. Root of negative 1 is I. Add a 3. And my two answers are 3 plus I and 3 minus I. These are imaginary answers because we have i's in them. Square root of negative 1 is that I we talked about. And remember, we get 2 of them because they did a square root to get rid of a square. So now if I go back to Desmos and I graph that, since I have 2 imaginary answers, it's not going to cross my x-axis. It's not going to be anywhere down here because my answers are imaginary. When your answer's imaginary, you just have to cross your fingers and hope you did it right. All right? We have no Desmos ways to check imaginaries. It won't let us. All right, so there's number 2. All right, number 3. We're going to do the quadratic formula. But let's do it backwards this time. All right? Going over to Desmos, if I graph number 3, it doesn't cross the x-axis. So that tells me automatically that I better have an I in my answer. All right, quadratic formula. Negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Going back to this problem, 9x squared minus 6x plus 5. My a is 9, my b is negative 6, and my c is 5. Substitute those numbers in and do the math. Clean it up the best you can. Go ahead and pause it at some point because I'm going to start working on it right away. So pause it so you can do the work ahead of me. All right, so first thing I'm doing, I'm just substituting them in. So that's negative 180 over 18. Which is going to be 6 plus or minus the square root of negative 144 over 18. And this is going to work out pretty. I'm going to move it over here so I don't have to write at the bottom of the page. 6 plus or minus the square root of negative 144 is going to be an I because of the square root of negative 1, and 144 is 12. Square root of negative 144 is 12i, so I get 6 plus or minus I squares of 18. Looking at this, these 3 numbers I can factor a 6 out of. So I get 1 plus or minus 2i over 3. That's the answer I like. They may write it as 1/3 plus or minus 2i over 3. That's also acceptable, but I would prefer it like the circled. So there's no reason to take it apart, but if you see it the other way, we need to be able to do that. All right, so these last 2, since they don't cross, I found 2 imaginary solutions. So the first one had 2 rational solutions, good answers. The second 2 had 2 imaginaries. If I gave you an answer like this, 1 plus or minus the square root of 7 over 2, and that was my answer, we would say that's an irrational answer because the irrationals have square roots and crazy decimals. All right, so we have to be able to solve these on the worksheet. Do whatever way you think is best. All right, but I want you to do factoring, quadratic formula, completing the square, or just solving. Don't just go to the calculator because going to the calculator on 2 of these problems doesn't give you an answer. So it does you no good. And I say it a lot, I want you to know the math more than just being able to plug it into Desmos. All right, number 4. Absolute value of x minus 3 is greater than 1. Absolute value of x minus 3 is greater than 1. All right, we have a compound inequality. Compound inequality, compound absolute value inequality. Make it even bigger. All right, so we're going to have to write two absolute values. All right. And we're going to put a word between them. So to write my two absolute values, I'm going to write x minus 3 is greater than 1 as my first one. Just leave it as it is. And then I'm going to write x minus 3. I'm going to switch this and make it less than the opposite, negative 1. So the two I'm going to solve are x minus 3 is greater than 1 and x minus 3 is less than 1. Now, the word. To figure out what word we put between them, I'm going to write this as greater. All right, greater makes it an or statement. So I'm going to put the word or between it. I'm going to solve both. I'm going to graph both. Open circle because it's just less than and greater than. And because it's an or statement, what I want are all of the possible answers. So since it's an or, this is my solution. I want both pieces. So I want all the values that are less than 2 or greater than 4. I want to take these two statements and put them together. All right, so going to Desmos. If I graph that, this is what I get. Everything is shaded except between 2 and 4. And it's a dashed line like an open circle saying that it doesn't count. So these two pictures are the same idea. All right, so let's look at number 5. And I'm going to graph number 5 to start. All right, I'm going to graph number 5 to start. Looking at this, I'm at -2 and -4 with solid lines, which means I want to count those numbers, and I want everything between it. All right, so let's see if I can make that graph, this graph right here, happen solving it. So I'm going to write two inequalities. X plus 3 is less than or equal to 1. X plus 3 switches greater than or equal to the opposite, -1. This symbol for this problem is a less than. So it's an and statement. Greater for an absolute value inequality or less than. So now I'm going to solve both. X is less than or equal to 2, and x is greater -2, and x is greater than or equal to -4. Close circle to the right at -4, close circle to the left at -2. And since it's an and statement, I want what they have in common. So my answer is going to be from -4 up to -2, close circles both times, which is what we have here. I want what's between -2 and 4. All right, number 5. Absolute value equation. A little bit simpler. We don't have to graph. But we're still going to find two answers. I'm going to write two equations here. I'm going to write x minus 7 equals 5, and x minus 7 equals the opposite, which is a -5. So I write x minus 7 equals a 5 and a -5. I solve both. And those are my two solutions. Easy as that, write it. Left side stays the same. What's inside the absolute value bar stays the same. And you set it equal to that number on the right and the opposite of what's on the right. All right, going to Desmos. Why does it? Okay. There we go. Now if I zoom in a little bit, not too far. My two solutions are where it crosses at 2 and at 12. All right, at any point you're going through this and you have major issues, send me an email. Ask a question, I can answer it. Or look it up online and see what they have to say. All right, number 7, I'm going to solve. The square root of x minus 4, add 5 equals 9. All right, we're just going to straight solve this. So I'm going to subtract the 5. You got to get the square root all by itself. I'm going to square both sides to get rid of that square root. I get x minus 4 is 16. I add 4. I get x to be 20. You cannot square both sides until you get the absolute value all by itself. So I'm going to go to here. I'm going to type in the problem. And it crosses at x equals 20. So that tells you that that answer is correct. All right, so all of these, what we're going to do is we're going to graph them and look at the pictures and find out where they cross the x-axis and what's shaded in what direction. All right, number 8, a rational equation. For a rational equation, what we're going to have to do is we're going to have to factor our denominators. We're going to get common denominators. We're going to find out where the graph does not exist, and then we're going to solve. All right, so I'm going to factor. X minus 6, x plus 1 are my factors for this piece. So I'm going to write 4 over x plus 1, the original problem, plus 1 over x minus 6, x plus 1 equals 1 over x minus 6. All right, my common denominator is going to be both of these pieces. So I need to put an x minus 6 on the top and the bottom of the first one, an x plus 1 on the top and the bottom of my second one. We are going to have two values that are not going to be good answers. If I get those answers, I'd have to get rid of them. They're going to be my denominator equal to 0. So I would set both of these two equal to 0. So x can't be a positive 6 or a negative 1. Because if I put negative 6 or positive 6 in there, I get a 0 denominator. If I put negative 1 in, I get a 0 denominator. All right, next, I'm going to take the equation across the numerator and write it out. 4 times x minus 6 plus 1 equals 1 times x plus 1. Distribute. Add like terms. Solve for x. And I get x equals 8. Pause this video if you need to catch up. All right, now I'm going to say 8 is a good answer because it's not 6 or negative 1. All right, so I factored. I got common denominators. I wrote the equation across the top and solved. All right, so now I'm going to go over here to number 8 that I have on this and graph it, and yep, it crosses at x equals 8. So I know I did it right. All right, when you take the test, if you feel you need to, truly for this one, you're just going to type it in and find out where it crosses. All right, last one we're going to do 3 times because that's what we did when we did this lesson. We solved it 3 ways. All right, this is a system of equation. 2x plus y equals 7, x plus 3y equals 6. So what we're going to do, 3 different ways. First way is we're going to graph. So what I'm going to do is I'm going to take all 3 of these. Well, let's not even do that. All right, I'm going to take both of those. And I'm going to type them in the Desmos the way they are. Let me get rid of that and give me that. All right. The first way we can do this, and I do not want you to do this every time on your homework. Do it maybe once, and the other way is by hand. I graph both of them. My solution is going to be the point where they intersect each other. So just graphing this. I get the solution 3, 1. All right, when you do take the test, that's fine and acceptable. But for me, until the test, we're going to do it 2 different ways. So all I did is I typed both of them in and found out they intersected at the point 3, 1, circle that answer, and be done. All right. On some of the problems, when they ask you to solve, they're going to want the x value of the answer or the y value. If they want just the x or the y value, do not give me the ordered pair. Tell me my x value is 3 and your y value is 1. So make sure you read the directions. All right. Next way. We're going to do substitution. For substitution, I'm going to pick one of the variables, and I'm going to substitute into the other one. All right, so I'm going to pick x, just because. I'm going to get that x all by itself. Now I'm going to take that expression, which is what x equals, and I'm going to substitute it into the other problem. So I'm going to have 2 times my negative 3y plus 6 plus y equals 7. Now I'm going to solve for y. I get y to equal 1, which is exactly what I had on this first one from the graph. Now to get my x value, I'm going to take y to equal 1 and plug it into that expression I have. And I get the same ordered pair. So that is substitution. I expect to see not just graphed and answers, some work involved. All right, let's get that same answer one more time. This time, we're going to do elimination. All right, so we're going to pick a variable to get rid of, and I'm just going to choose x's. I'm going to force my x's to cancel. To do that, I'm going to multiply this bottom line by -2 to force them to cancel. So I leave the top one the same. Multiply the bottom by -2. Add down. Cancel. -5y equals a -5. Y equals a positive 1. Wait a minute. Yep, exactly what I got both other times. I take this 1, I plug it here or here, solve for x, and I'm going to get x to be 3, which is what I need it to be. That's the lesson for Tuesday. This is not going to be due until the following Tuesday, because on Thursday we're going to come in, work on a quiz, a little cumulative assessment on the first 2 days, and then you'll have time to work on this also on Thursday. If you have any questions, send me an email at any point. And if not, I will see you on Thursday. Have a great one.